Einstein's birthday
Yes,
party.
welcome to his 12th birthday.
Wow, this is so exciting.
Yeah, did you bring the pong ball?
I brought the ball.
That's a tennis ball.
Yeah.
Oh. We're playing pong.
Oh, this isn't gonna work.
You know what? We'll make it work.
We'll make it work.
It's fine.
It's okay.
Let's go.
You know what? Adapt, improvise, overcome.
You're going down. Go.
Hey, wait, what are you guys doing?
What Einstein loved most.
Physics.
Yeah.
True.
All right. Watch me cream Naomi right here. Go.
I don't know, man.
Ha! Wrecked.
Here we go. My dream is to one day beat Frazer in PONG, but I don't even know how to get this shot. It's too much pressure.
Wait! How can you expect to get the perfect shot without physics?
What do you mean?
Well, this is a classic projectile motion problem. Let me show you.
Wow, physics girl, that's a great idea. I think I get it. So, in projectile motion, you have two components, the x component and the y component. In the x component, there is 0 acceleration. And in the x direction, we denoted the starting point as 0 and the final distance as 1.97 meters through a ruler. And we know that since the acceleration is 0, the velocity is constant, which means that v equals the change in distance over the change in time. And by using a simple stopwatch, we found the change in time to be 0.59 seconds. And through a simple calculation, v equals d over t, we found that the velocity in the x direction is a constant 3.39 meters per second forward.
Our second part of this physics equation includes the y component. So unlike the x component, which didn't have anything acting on it after it was released, which is why the velocity remained constant, the y direction actually had an acceleration due to gravity that was acting on it throughout. So this was equal to 9.8 meters per second squared. And we also denoted that our direction in the y would be downward as positive. So this is why when we took our initial distance of 0.63 meters, which is where I started off with the tennis ball, and we ended at 0 meters inside the cup, we had a positive delta y of 0.63 meters downward. So when we take this into our kinematics equation, we used delta y is equal to the initial velocity in the y direction times time plus half of the acceleration in the y direction times the time squared. So when you plugged in all of our numbers into this equation and isolated for the initial velocity in the y direction, we got a negative number, negative 1.823 meters per second. So since it was negative in the downwards direction, this would indicate that it is a positive speed in the upward direction.
So now that we've discovered the velocities in the x and the y components, we can figure out the initial velocity overall. So if you just draw a simple triangle, we figured out the x velocity was 3.39 meters per second, and the y direction velocity was 1.82 meters per second. So using Pythag, our main man, we get this equation right here. And then taking the square root of the x velocity plus the y velocity both squared, then we can figure out that the initial velocity is 3.85 meters per second. And then if you want to get the correct angle for your PONG shot, you can use tangent theta to figure out the angle to the horizontal, which is 28.2 degrees above the horizontal. So in conclusion, to make the perfect PONG shot with this size table and with Naomi's height, you need to shoot the tennis ball at 3.85 meters per second forward and then 28.2 degrees up. So does all this physics fun make sense to you guys?
We're just here for the food.
By Starbucks.
Oh.